So to wrap up the discussions of atomic classes and operations, let's talk a little bit about some of the usage considerations to make them work effectively for you in practice. The first thing to remember is even though we're using this for our programming assignment, you should be very careful when you use atomic operations in practice, because if you're not careful, you can end up doing what's known as busy waiting. And in some situations, busy waiting is good, right? If you're writing a nuclear reactor control program and you want to make sure the temperature of the core stays, below a certain value, then you might want to busy wait, because any delay in detecting the core getting too hot could be, disastrous, right? So there are some situations where busy waiting is a worthwhile thing to do. There's also other situations where busy waiting makes sense if you don't have much contention, because you'll get the thing very quickly, you won't have to block, you're optimistic it's just going to work. However, there are other situations where busy waiting can cause trouble. And that is when busy waiting ends up needlessly wasting CPU cycles. So if you have a lot of contention, there's a lot of threads trying to access a critical section, then if you're not careful, they'll all sit there spinning and not really getting anything useful done, just spinning and getting really no benefit. So busy waiting should be used thoughtfully. There are, of course, some reasons why you want to try some spinning. And if you watch this video by my buddy Doug Lee, he talks about why multi-core processors, why platform code, infrastructure code, like the Java class libraries and the fork join pool and all the good stuff that we'll talk about later, why they do a little bit of spinning. And that's because you really want to try to avoid blocking, if at all possible. Modern multi-core processors have tremendous penalties if you block them. And that's due to the overhead of context switching for sleep locks. We'll talk more about sleep locks later. But sleep locks are basically when you block. So you actually put yourself to sleep. And a modern multi-core processor really doesn't like to sleep. It likes to keep running. It's not optimized for sleeping. The compare and set methods in the Java atomic classes, like atomic Boolean, atomic long, atomic reference, all the good stuff that we're doing here, they give you a way to access these hardware primitives that come on modern multi-core processors without you having to be aware of how they actually work under the hood. So they don't really expose to you the details of compare and swap long, compare and swap int, which are part of the Java unsafe layer. Instead, these are exposed to you through the atomic classes, and they give you lots of other cool goodies to make life easier for what you're doing. Okay, any questions about any of that?